Welcome to Sairam Tribuli YouTube channel. Let us discuss second concept. Of your third module, computational tools of smart grid optimization techniques. So the name itself indicates there is a techniques involved to reduce the power supply consumption and power supply losses and losses in the power transmission distribution and increasing the power consumption and then usage also. So optimization technique consists of static and dynamic techniques. So static in sense constant techniques. Dynamic in sense changing. It depends upon certain parameters, certain values. As a linear programming, mixed integers will be there for the optimization technique solving the problems. Right? Next, classical optimization methods, linear programming. Linear programming, so see here, it's a mathematical, right? Model describe the problem with a linear objectives, a linear constraints. If suppose some of the parameter depends upon this other different parameters. So if suppose one is varying and linearly it depends upon the another one. So similarly, for example, I'll tell you voltage and then frequency or whatever. So these are the concepts we are going to discuss and the problem solved in these methods. Also, some of the simulations will be there and algorithms will be there for the solving the problems, right? And dynamic programming, this approach was developed to solve the sequential multi-stage decision problems. So the name itself indicates dynamic programming. It involves sequential multi-stage decisions and like problems. So one by one, sequential, one to one, one to one, one to one. So multi-stage also will be there. Basically, it solves the multi-variable problems by solving the series of single variables problems. The name itself indicates dynamic programming. It's a programming to depends upon the changing the program or changing the values and then changing the external parameters. It depends, right? Next, there is a stochastic programming, a chance to constrained programming CCP. Stochastic programming solves LP problems. So um, whereas the uncertainty assumption is and so badly violated that the same parameters must be treated explicitly as random variables. There are two ways to handle the LP with a variability or stochastic programming and chance constrained programming. So these are the two methods programming chance to constrain the programming CCP. Right. Next, there is the heuristic optimization. Future work that accounts for the predictive and stochastic nature of the smart grid involves modeling components to account for a predictive and stochasticity, selecting the new optimization methods such as adaptive dynamic programming. So adoption must be there in the operation. So next, there is a evolutionary computational techniques based on the natural genetics. Evolutionary computational solves the combinatorial optimization problems, the techniques in this category, right? So adaptive dynamic programming techniques, adaptive ADP incorporates time dependency of the deterministic or stochastic data required for the future. ADP is also termed reinforcement learning, adaptive criticism, neural dynamics programming, and approximate dynamic programming. These are the programming methods involved in the adaptive dynamic programming. Uh, See here, there is a one diagram. There is x of t is a variable, dynamic model of a system. There is a interconnection of a critical network and an action network. So derivative calculated by the back propagation, and j of t is the other one output and input will be there. See here, one to one connection. uh, Finally we will get a action network. So derivative calculated by the like deriving, differentiating the different constraints and different parameters. So these are the three blocks we are using, and one to one connected. A dynamic model system consisting of changing the values, changing the supply system, or there is changing the parameters, right? So critical network and action networks are the two sub divisions. So next there is a hybridizing. Next there is a hybridizing optimization techniques and applications to the smart grid. To facilitate the computational methods, we incorporate with the hybrid intelligence system. such as immunized neurosystem and immunized swarm system, neurofascia systems, neurosystem swarm systems, right? So hybridizing, adding two or more techniques in the power system smart grid, right? For the application of smart grid. Next, computational computational challenges. The computational challenges associated with the utilization of advanced tools involve their optimal selection based upon the specific applications and locations, data availability, and other challenges. So, computational challenges. Suppose this is one basically challenge. Initiating the power system into smart grid or smart grid into the power system components, existing system. So, uh, it should match some of the components, and then whatever we are making the programs or whatever we are making the automations, that must be support to the present operation or present grid. So that is the major mm, operation in the computational challenges. So we are facing while designing the smart grid or while mm, making the power supply system into the higher level. So uh, challenges, power supply for failures and power variations occurs, or something disturbance occurs in the while implementing the smart grid into the present grid. So that challenges we have to face. And even though variations occurs in the voltage levels or the current levels and the power variations and designing variation, different skills will be there, and different skilled persons are working, and there different parameters are affected to the power system analysis techniques, right?